Hello everyone, we are going to learn about wired computer networks today in this chapter called computer networks. And first of all, we'll learn about type of network based on communication channel or media. To connect computers or communicating devices to each other, there must be some kind of transmission media or channel over which the data can travel from one computer to another, and the selection of that media depends upon the various factors like cost and data transfer speed, bandwidth, and your distance. There can be two kind of media like guided and unguided. Guided means wired and unguided means wireless. And wireless media is of course the cables and which are used in normal LAN type of network, and wireless media is like infrared, radio frequency waves, satellite links, electromagnetic waves, etc., where the environment or air is used as a media. So if we see the classification of two kind of media, first we see the guided media. In guided media, we have twisted pair, coaxial cables, as well as optical fiber cable. In case of unguided media, we have infrared waves, radio waves, microwave, satellite, and Bluetooth or Wi-Fi. Now, wired network media. In case of wired or guided media, it's a physical conducting media which is comprising of twisted pair cable, coaxial cable, or fiber optic cable for transmitting the data over the network. Wired networks are also called Ethernet networks, which are normally used in LAN. Ethernet is also the fastest wired network protocol and has a connection speed from 10 Mbps to 100 Mbps or even higher. The twisted pair cable or the Ethernet cable is mostly common type of media which consists of 4 insulated pair of wires twisted around each other and is used for creating small computer networks and extensively used for LAN. The twisting helps to reduce the crosstalk and electromagnetic interference effects. Cat5 and Cat6 specifically are mostly used in LANs. So RJ45, that is a registered jack 45 connector, is being used to connect the cable to a computer normally in LAN. If we see the twisted pair cable, they are of two types, shielded twisted pair and unshielded twisted pair. The shielded twisted pair has some extra insulation to further reduce the signal interference. Advantages of twisted pair cable: they are low cost, low weight, and flexible cable, thin and flexible cable, and therefore easy to install and maintain. And the disadvantages are they are suitable for short distances only, that is up to 100 meter. A repeater is required for the long distances, and they support low bandwidth and offer speed up to 100 Mbps only. If we talk about the coaxial cable consists of two solid insulated conductors that share a common axis. The inner conductor is a straight wire surrounded by a wired mesh, each separated by some kind of foil or insulator. The inner core carries the signal and outer mesh provides the earthing of the ground. Cable TV network is the most common example of coaxial cable. And here we can see the wire mesh as well as the inner core, the center core, and dielectric insulation, the metallic shield in the case, and surrounded by a plastic jacket. Here there are advantages like high bandwidth from 180 to 500 meter longer distances. It can carry the data also, and suitable for broadband transmission like in cable TV networks. It is less susceptible to electromagnetic waves in comparison to the twisted pair, and it is disadvantages are less flexible and basically expensive than twisted pair cable, not compatible to UTP-STP, and due to its thickness, which is 1 centimeter in diameter, and poor flexibility, is difficult to install it in comparison to twisted pair. So if we come to the third type of cable, that is optical fiber cable, it consists of long thin strand of glass-like material of some high-grade plastic, which carries the light signal over the long distances, and light or the photons are transmitted instead of electricity over the glass or plastic medium, and signals are modulated and transmitted in the form of light pulse, and whose source is LEDs or laser. When we see a bundle of optical fiber cables, it is called as like light pipes. After that we come to its components. Fiber optic cable has core, cladding and buffer coating. Core is the glass rod or the thin plastic conductor, plastic part through which the light actually travels. I'm not using the term conductor because it is not carrying the electricity, but it is carrying the light signal. Cladding is the part which reflects the light back to the core, and buffer coating is the plastic coating which protect the cable from damage and moisture. We see here, this is optical pipe consisting of many optical fiber cable, and here we can see the core surrounded by cladding, then coating, after that strengthening member and outer jacket. Here is the principle called total internal reflection, using which the light travels in a optical fiber cable. When the light enters to the inner core. Core is actually the rarer medium, and cladding is a denser medium, having refractive indexes N1 and N2. And when the light enters into the rarer medium, that is the core, and it strikes the denser medium, then as the angle of incidence is more than the critical angle of the two mediums, then because of this property, that is called total internal reflection, the refraction doesn't occur. The light is not refracted but reflected back into the same medium. In this way, it keeps on traveling by total internal reflection, keeping the light in the same media, that is core. Its advantages are like it's free from electromagnetic interferences since no electrical signal is involved, and offers secure and high speed transmission over long distances. Most efficient cable in case of computer networks. Disadvantages are most expensive cable, quite fragile, and installation procedure is quite complicated, and it's not easy to join to broken fiber, and so obviously it has high maintenance cost also. If you want to select one of the best out of three, there is no such parameter, but it depends upon the cost and data transfer speed and bandwidth and distance, whatever you want to choose from. If we compare 4 parameters like the data transfer rate, it's minimum in case of twisted pair cable 10 Mbps to 10 Gbps, and like coaxial cable it's 100 Mbps, optical fiber more than 100 Gbps. In case of the distances, if we see like the distance is 100 meter in case of twisted pair cable, and up to 500 meter in coaxial, and more than 10 km in optical fiber cable. EMI, electromagnetic interference susceptibility, is more in twisted pair and lesser in coaxial cable, and nil in optical fiber. If you want to see the cost is least in case of twisted pair cable, more than twisted pair cable in case of coaxial, and very expensive in case of optical fiber. It depends upon quality of the type of thing you want to implement. And you can refer these 2 books for this topic, and feel free to ask questions on this topic. See you in the next topic. Thank you.